Hi friends, today we are going to see about the introduction in highway engineering. So for today's video, we will be having just an introduction and overall view of what is highway engineering and how we are going to study the highway engineering in civil engineering field. So today we are going to see these topics. First we will see about the introduction of this highway engineering, then why do we need to study that highway engineering, then what are the various branches in highway engineering, and then a brief overview of all of them. So in next consecutive videos you will be seeing each of them and further into detail. So today, what is this highway engineering? So highway engineering comes under a branch of transportation engineering. So transportation engineering, one of the branch of transportation engineering is highways. Another one is railway engineering. Then airport engineering. Then harbour engineering. So these are the main branches of a transportation engineering, that is roads, rails, air and waterways. So these four methods we can travel from one place to other place. The main purpose of this transportation engineering is to make a safe and reliable movement of people and goods. It should be safe and it should be reliable. Most importantly, it should be also economic. So the engineering focuses on the three scopes, that is safe, reliable, fast, also including the economics. So this highway engineering is mainly concerned about the roads, how we can concentrate on the efficient movement through roads. So under highway engineering, the various branches can be classified as planning, then geometric design, then pavement engineering, and then the traffic studies or traffic engineering. So these four are the main subdivisions under this highway engineering, that is how to plan efficient traffic or efficient movement of vehicles over from one place to other place. It may be a small or shorter journey or it may be a long journey. And then the geometric design. Geometric design means that how we can efficiently plan a road pertaining to X, Y and Z axis. And then about the pavement engineering, how good we can construct a pavement or how optimistically we can construct a pavement. The pavements commonly you can see are bitumen, that is the black top is known as the bitumen pavement, and then the white top, that is the cement concrete pavement, and also there may be an overlay of them. So on those things, how we have to characterize the pavements, how we can design the pavement efficiently. Under this pavement engineering, there are several subdivisions, that is materials, study about the individual materials of the pavement components, and then the design, how we are going to use that materials, that is known as the design, how we can design the quality and quantity of the pavements, and then the construction, what are the several ways of constructing a pavement. It may be both bitumen or as well as cement concrete, or another type is there, that is known as the WBM, WBM pavements. So a lot of construction techniques or procedures are under this pavement engineering. And then the maintenance and evolution. So how we can maintain the pavement for improved quality, or how we can check the quality, that is known under the maintenance. How we can evaluate the maintenance by various methods. So these are all coming under the pavement engineering. And then last one is the traffic engineering. So traffic engineering is a very high important area in the highway engineering. Concerns that within the given amount of time, how many vehicles can pass or how many vehicles can move very easily, how we can plan for that. Simply we cannot keep on building the bridges, or simply we can't widen the roads, or simply we can't build huge lanes, 6 lanes, 12 lanes, 15 lanes, how many lanes we can keep on building. That is not feasible. So there traffic engineering comes into play, where the study concerns about how we can optimize or how we can efficiently move the traffic very easily, and how we can regulate such that the amount which is being spent from individual as well as the contractor or as the constructor, whatever view we can see, how we can optimize the amount for to yield a high output. That is known as the traffic engineering. So this is the overall view where we are going to see the highway engineering. So this railway, airport and harbor engineering you will be seeing in the separate videos. That is a separate subject or separate areas we have to see in detail. So first one is the planning. So how we can plan? What is meant by planning? So whatever work we do, not even just come out of this highway, just you think of whatever work we do, even a small daily day-to-day work or a long-term work, we have to plan each and every move that we are making, so that the amount of energy we are spending, amount of money we are spending, everything will be sufficiently reduced. Or in other words, you can see it is optimized. How we can optimally plan for anything to happen, any work to happen. Same way, in the planning side, what we have to do is we have to study about how we can plan the movement from one place to another effectively. So here the planning part comes into picture. So it may be from origin to somewhere a place destination. How we are going to plan or how we are going to connect these two roads such that the time, the energy and the environment is to be taken care of. How we can take care of all the time, energy and environment. Simply we cannot put the route from origin to destination, or say from A to B. If you are planning from A to B, simply we cannot just keep on adding number of buses or keep on adding number of vehicles, or simply cannot give a metro, or simply we cannot give a rail network. So we have to plan everything how efficient. Suppose if there is a town C, so if it is possible to connect this from A to C and then to B, will it be optimized or will it be economic, or just A to B is economic or A to B is optimized, etc. So this planning part is the most important, one of the most important areas in the highway engineering. So in this we will be studying about how we can, what are the various methods. So they will be seeing that the main principle of planning is where is the people are generating, where they are going, and from where to where, how they are going, that is by which mode they are going and which way they are taking. So all those points will be taken consideration, and then we will study about this planning. The next important core is geometric design. So geometric design involves in two planes, that is horizontal and vertical. So if you are, for example, if you are taking a video from above the sky, say satellite image, If you are taking the satellite image of a particular section, say taking a satellite image, this is a road. So how you can plan the alignment of the road? Whether this road is okay, whether the radius of turning, how the vehicles are turning, whether it is correct, and whether the people are seeing the other obstruction, whether the road is visible ahead, how much it is sufficient, all those will be coming under the horizontal study, that is known as horizontal alignment. How far you can make the radius of the roads, or how we can see a distance from here to here, what is the sight distance, that is known as the sight distance. So how we can see the object, oncoming object or oncoming vehicle, also the object is stationed from distance, how fast the vehicle will be going so that he can see the object in front of him. All those things will be studied under the horizontal alignment. Next is vertical alignment. So vertical alignment is nothing but the ups and downs. So ups and downs. So what is the up? This is known as the sag curves or valley curves, and this is known as the summit curve. The going up the gradient is known as the summit curve, and going down is known as the valley curve. So how far the slope should be, or how steep the slope should be, or how steep the gradient, incline gradient should be. So studying all those things will be coming under the vertical alignment. This horizontal alignment and vertical alignment is the main core in studying the geometric design. Next is the pavement design or pavement engineering. So pavement engineering includes the materials. What are the materials that we are going to use? Say mostly we will be concerned with the aggregates. That may be fine or that may be coarse. And then bitumen or concrete and cement, all those things. Then these are all concerned about the materials. What is the quality of the aggregates you are going to use, what is the quality of the bitumen you are going to use, and what are the tests that are going to be conducted for testing the materials to check the quality. All those will come in the material side, that is known as material characterization. The next one is the design. So in pavement engineering, the main two types of designs are, one is concerned about the bitumen design or flexible pavement design. And another one is the rigid concrete pavement design. So these two are the important design pavements in the pavement engineering. So how we are going to design the flexible pavement and how we are going to design the rigid concrete pavement. So these two pavements will be coming under the design part. Mostly we will be concentrating on this. And other types are also there. That also we will be seeing when we are discussing this pavement engineering. Then in addition to these to these two things, there is the construction part. So this is also an important vital parameter present this century. So how you can efficiently construct a pavement? It should take less time, it should take less cost, but it should give more quality. So how the construction is going to happen? What are the various construction methods are there, and what are the various types of construction are there? How they are going to construct, and what are the equipments needed? All those things will be studying in detail in this construction of the pavement part. Then next one is maintenance. So how much we have done the construction part, how much quality we have checked, and how much time we spent in constructing the pavement, whatever energy we have spent, but the main part is the maintenance. We have to regularly check, or we have to regularly maintain the pavement. So what are the procedures and what are the methods of maintaining? Those things will be studying in detail, right? Then last one is evaluation. How we are going to evaluate the payment. So initially the quality is done for A class. Now what class it is, whether it has reduced below the class which we have originally designed, or how we can improve the class, or how we can strengthen the payment, or how we can improve the quality. That will be studying under the evaluation part, evaluating the structural performance or evaluating the non-structural performance of payments. So these are all will be coming in the payment engineering. And last one is traffic. So traffic engineering, I have told you, it is a very important for this present century or present day-to-day needs, because with the given amount of resource and given amount of time, how we can optimize the movement of men and goods, the movement of passengers, also the movement of goods. So traffic engineering plays a vital role, and there's a lot of modeling involved in the traffic engineering. There's very statistical models, and also various logarithmic models, and also a lot of hypotheses are given based on the traffic engineering. It's more or less related to somewhat statistics, right? Statistics, how we can forecast the traffic, what is the present traffic, and how we can interpret it for the future work. So all these things will be coming into the traffic engineering. So traffic engineering, there are a lot of studies involved in traffic engineering, such as signal design. I'm just talking about the core traffic engineering concepts. So first one is the signal design. How optimistically, how efficiently we can design the signals. How much time we can give for a waiting, and how much time we can give for a go signal, etc. So all this comes in the signal design. It also includes for the pedestrian movements also, right? And then about the regulations, like how we can regulate the present traffic channel, traffic movement or traffic flow. All those things will be the traffic signs, signals, what all those things used in the traffic engineering. That will be coming in the regulations. And most importantly, a lot of parameters you have to study in depth, such as speed, density, volume, capacity. Like a lot of parameters are there. So a lot of parameters are there. So speed, density, volume, capacity. So these parameters you have to take into consideration, and then we have to analyze the movement of the traffic. So after analyzing, we can come to a conclusion that keeping a one-way street or keeping a two-way street, or how we can keep a no entry, or how we can change the route of the vehicles which are traveling. So all those things will be studied in the traffic engineering. So these are some important overview or highlights of a highway engineering. So each component we have to take it into account and study thoroughly. So in forthcoming videos we will be seeing the planning, geometric design, pavement and traffic in detail. Thank you.